Alright, I'm trying to. I'll try to do the. I'll try to do the 1800s photoelectric effect, and also the 1900s photoelectric effect, and also try to do special relativity in Earth's atmosphere, and general relativity. General 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 relativity in space, because essentially one is air and the other is empty. And also just review constant squared when mass is available observably, meaning that there isn't necessarily, well, there is a distinction between, well, there's a distinction between Bohr atom and kinetic energy, in that there's a subatomic and there is a naked eye observable, and those are both those are both available, and saying that's energy, instead of actually incentivizing kinetic energy, you can just take energy, you can just waste energy essentially in cosmic inflation. Uh, Cosmic inflation technically is a waste argument, rather than a rather than a technically cosmic inflation is a waste argument rather than a work argument, as Big Bang would be. Big Bang is obviously a work argument, but in cosmic inflation you have Boltzmann's brain, and the obvious answer is you want to be a brain in a you want to be a floating brain in a infinite vector space, and so your vectors are your BBs or your Big Bang, and I'm just saying that would be the obvious answer. So it seems right now for uh, Bateman's brains, or sorry, Boltzmann's brain. Oh, fuck. All right, really sorry about that. So that would be the obvious answer for me for cosmic inflation. I'm not saying cosmic inflation doesn't have to be an expansion theory, as it were with the Big Bang. It can be a waste argument, since there is uh, since there's no real. I mean, I don't know. I just don't think there. I don't know. I'll think about that one. But anyway, and then if you have an infinite vector space, and you're a floating brain, and these are big bangs happening, then you will be able to derive a general relativity in. Uh, you will be able to derive a general relativity, um, from essentially space gravity, space gravity. Earth, but yeah, Earth gravity, acceleration, and all that. In special relativity, you can also see, um, with Boltzmann's brain, because I mean, I'm just saying, yeah, you're gonna have to have basically like an observable, like when In the 1800s, particle electric theory, there is a photon that replaces an electron, and the electron goes to 2D. The electron goes to the second dimension, and the photon replaces that. And essentially, if if you had ten photons hitting these electrons, they would hit them in a row, and that would essentially, or sorry, the more electrons you have, the more reflection there is. The more electrons you have, the more electrons go to the second dimension, and the more the photon is able to pass. Okay, depending on your light structure and all that, or how you would construct light, that would depend on how much reflection is. So you see in a double glass mirror experiment, that you need a lot of light to be able to reflect off of the electrons. Um, but when you turn off the light and you don't have any light, uh, photons from the other side of the mirror will be able to be seen just because of the structure of the electrons. So again, um, in the 1900s, particle electric theory, you just have you could have something as simple as the sun in the sky, and the sky is blue, and the sky is blue because it is reflecting off of Earth. The sky is blue because it's reflecting off of Earth, and in the night sky, you don't get a blue sky because um, there is no UV, and so you again you don't get a reflection. But my point is, you can see through the double glass mirror because yes, the photons are strong enough, or the electricity and the magnetism, the charge created in the photons and the light is strong enough to not only reflect but also pierce through that reflection. And so basically, your you have a reflection in the blue sky, you have a reflection in the night sky, and those are your two constants in a world of mass, or in your universe of mass. Um, and you're seeing that as energy. I don't have a problem with that. All right. Yeah. So you also have obviously I'll say force equals mass times acceleration. I think I covered all of the particle electric effect, because I mean there's always just going to be two constants. One that you have with a one that you computate. Well, I should say computate. That'll be one constant, and then your other will just be your naked eye observable. I mean, it doesn't have to be your eye, just your sensation observable, and that would be your other constant. But you have to realize that there is real artificial intelligence, because I mean, you're not saying. I mean, I guess that brings me back to the argument, but just because the zombie argument is implying that if I say uh, that there is real intelligence, I don't have to say there's real intelligence if I just say it's a constant. So it wouldn't make a difference. All I have to say is that there's a constant universe. I mean, I could say that there is a constant universe with structural or constructive alignment and cogeniency. Um, and then there's a constant universe that I observe sensically, or through my senses. And so, I mean, that's a conditioned thought, and you say, well, that thought exists with mass. That thought has to exist with mass. Um, so you're still in a line, I would say, in thinking. And if you say that it equates to energy, then you can derive that you have basically a choice in many worlds. I mean, you could say with many worlds that you have choice. I mean, many worlds doesn't have to be decided. Like which world, okay, which decision you make in the many worlds equation, which I should learn. Oh yeah, I mean, I'm basically just saying, if you can utilize, I'm sure, a many worlds equation, or you can just always use your constant and get into the other equations to be able to figure out the uh to be able to figure out particles. And I'm just saying I like it. I guess it's probably unorthodox to say that you need like a sensitive, observable human experience to be able to procreate a uh, constant, infinite, kinetic, energetic, gravitational, magnetic universe, or propulsion and particles. I think that's a little bit unorthodox to have um, that dark inversion or necessity, but it does elaborate on that you have uh, an extremely large world in a subatomic world and an extremely basic uh, world, an extremely basic mechanical world in what you observe or feel, etc. And I think that falls in line. 'Cause of course, in string theory, I use radius or radioactive decay. I mean, all these things just measure up and inversely construct. Well, I guess it's constructor theory now. Um, inversely can construct something like distances or lengths of the entire um, sphere or cube. Or, yeah, I mean, I don't think it's a problem to say something like logic if we are necessitatively brains. So I do like Boltzmann brains. So if I have gravity, um, if I have gravity in alpha and a beta, it just means that I'm already in gravity. Um, I can understand gravity as I shouldn't understand it as I can understand gravity as mass one plus mass two, and that's me, the Earth, and distance squared in the measurement, and it's being held together by force, and I can understand that, um, and I can understand that there can be that truth, and then there can be something that I'm going to be able to, I guess, um, and yeah, there is something that I'm going to, well, I mean, there's not a psychic change. I'm not saying there's a psychic change. I'm just saying there's a psychic truth. That's all I'm saying, that there is a psychic truth. I wouldn't say there's a psychic change, like I'm doing this and now I'm doing that, but I'd say the psychic truth is that this is happening and I have a decision to make. So anyway, and then you have eight. I'm not sure about eight. I guess eight is how do I add two sides to well, yeah, I mean if I have a cube and then I have like a Minkowski I don't really understand Minkowski that well either. Yeah, I'm not gonna butcher the Minkowski right now. Um, I mean, I am kind of just butchering, but you have pi. Um, well, I'd say, I mean, to me, it just looks like that Minkowski space can be a linear uh, a linear understanding, and cube space is a linear understanding. And if you have a line through it, that would add two more dimensions. But you can say you can use I mean intuitively you can say, well, there's this world, and this I'm putting a thought in a box, and um it has a distance that it'll essentially go. I mean, I think that we have that ability. I did say everything was like extrasensory perception, but there has to be um real conclusive five sense perception as well. But we should be able to intuitively understand that different things are happening psychically, but that doesn't mean that they change. So that's also like a clear distinction between subatomic and naked eye. But anyway, you have something like that, and then you multiply it by pi, which I'm going to say is uh, I can't even remember what pi is. All right. Yeah. So I don't know if I missed recording all that, but I'm sure I'll talk about it again in the future. It was just many worlds, and I just kind of went through the equation, how it gives you four constants. You multiply it by time, time over space, spatial infinity, and you always get an observable. Um, you always get an intuitive observable, and just like a fifth a 5 sense observable that is sending signals to your brain and all that. So it's still a deterministic universe, but it's not infinitely deterministic. It's more of like a pi ratio, and that pi ratio again that was going into like a cube space or like a thought, and that recognition of Minkowski space to me is a horizontal um, through it, which is along the diameter of like this spatial pi, and and then you get four constants, so you get two in an observable universe, and then two in a subatomic one. You multiply that by spatial infinity or